Hello students. Okay. So today we are going to do the last part of the chapter of class 11 chemistry, atomic structure. We have already learned the Bohr's model, the Rutherford's model, the Thomson model, all the things, right? And we came to know that the electrons stay in the shells, the orbitals, and also in the subshells. Now today we will learn where these electrons will stay, in which shell, in which subshell, right? Okay, so this electronic configuration is based on some principles. The first principle is Aufbau principle. Aufbau principle. Okay, this Aufbau is not the name of a scientist. This Aufbau is not the name of a scientist. Many times I saw the questions coming in the NEET and in the IIT level that which formula, which principle is not on the name of a scientist. So this Aufbau. This Aufbau is a German word. The meaning of this word is construction, means the construction of an atom. The construction where it will show where the electrons stay. So, how is the principle? Suppose this principle is totally based on the energy level. The energy level of the orbitals. Energy, what should I say? Energy of orbital, or you can also say subshell. Okay? The energy of an orbital or a subshell. Now, always remember that the electrons always prefer to stay in the lower energy level. This is the basic theory of physics. All the electrons, they will first try to stay in the lower energy level. So, for this, we have to know which one is the lower energy level. So, the Aufbau principle states that electrons prefer to stay, or electrons, I can write, first occupy the lower energy level orbital. What happened to this page? Electrons first occupy lower. You can say lower energy level orbitals or subshells or orbitals. So electrons first occupy the lower energy level, or you can also say like this, that electrons filling, this will be in the increasing order or increasing order of energy, increasing order of Okay, so this is the basic of the Aufbau principle. The energy of the orbital of subshell. Electrons first will occupy the lower energy level orbitals, and electron fillings. Suppose there are 10 electrons, how they will fill? They will fill in the increasing order of the energy level of the subshells. Now let us understand what are the subshells. The subshells are S, P, D and F, right? So these are the subshells. Always remember, according to Aufbau principle, so first we need to know what is the energy of the subshell, right? Suppose there are 3 electrons. Now, how many electrons will stay in S? How many electrons will stay in P? So electrons will first go to S or will go to P, right? So to know that, we have to first find out whose energy level is low. S energy is low or P energy is low. So energy is directly, it's a rule, it's a principle. Energy of a subshell. Energy of a subshell is directly proportional. Copy all these things. Energy of a subshell is always proportional to N plus L. Now what is N and what is L? What is N? What is L? We know, like say suppose 1s1, 2s, 2p, then 3s, 3p and so on, right? Now see, this 1s, this 1 is N and S is L. Clear? Now S is L means, always remember that for S, L is 0, P1, D2, F3. Always remember this thing. So L for S is 0, always 0. P is 1, D is 2, F is 3. Clear? Understood? Now let us find out how to fill up. Suppose there is 1s1, 1s, then 2s, 1s, 2s, 2p, 2p, then 3s, then 3p, 3s, 3p, then 3d, 1s, 2s, 2p, 1s, 2s, 2p, 3s, 3p, 3d, then 4s, 4p, 4d, 4s, 4p, 4d, then 5s, right? No need to go further. So 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, then 5s, 5p, 5d, 5s and so on. Clear? Okay. Now we are finding the energy levels. So Aufbau principle is mainly based, or not based, it helps us to find the energy of the orbitals of the subshells. Now see here 1s, right? Here 1 means, what is the principle? Principle is N plus L. So here N means 1 and S means 0. So N plus L becomes 1. Here N means 2, S is 0. So N plus L becomes 2. P is 1, that means N plus L becomes 3. Then 3s, 3, N is 3, L is 0. So it becomes 3. Then 3 plus 1, it becomes 4. Then 3 plus D, D is 2. So 2, it becomes 5. Then 4 plus S, S is 0. So it becomes 4. Then 4 plus P is 1. So it becomes 5. Then 4 plus D, D equals to 1. So it becomes 5. Then 5 plus S becomes 0. So it becomes 5. Now see, that means what I can say. So here is 1. Here is 1, here is 2, here is 3, here is 3, 4, 5, 5, 5, 5, 5. Clear? Okay. P is 1. Yes. Okay. 1 is 2. Then 4p, 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 and 4p, 4p, 4d. Sorry, here I made a mistake. D is 2. So it should be 2. That means it is 6. So 3p is 4, 3d 5, 4s 4, 4p 5, 4d 6, and so on. 5s, right? Okay, now you see. Now what we said? We said that electrons will first occupy lower energy level, that means from an increasing order. So let us arrange this one in the increasing order. So let us arrange this in the increasing order. That means which one is lowest? The lowest one is this one, 1s1. So first electrons will come to 1s1, then 2s2, 2s. So 1s, then 2s, then 3. Yeah, now see. Now the problem arises. This is also 3 and this is also 3. Right? Then what to do? So there is one more rule. If or when N plus L is same, means here is also N plus L 3, here is also N plus L 3. Then what to do? Then at that point of time, always consider N. So whenever you will find that N plus L is same, like here 3 and 3, here 5, 5, 5. So at that point of time, what you should do? You should always consider the N. If N is bigger, that means energy is bigger. So here you see, this is also 3, this is also 3. Okay, now let's check for N. Here N is 2, here N is 3. So which one has lower energy? This one. So first I should write 2p, then I should write 3s. Understood? Here there is the problem, here there is the trick. Here you have to apply the brain and you have to apply this formula. So 2p also 3, 3s also 3. But N, C for N. Here N is 2, here N is 3. Sorry. That means this one will have more energy. So first electrons will come and fill up 2p, then it will go to 3s. Okay. Then after 3s becomes 4. Now see, this is also 4, this is also 4. So which one? Here N is 3, here N is 4. So 3p. After that, after 3p, 4s. After that, 4, then 5. So 3d, then 5p, 4p, then 4s, sorry 5s, then 5s, and then 6 4d, and so on. Clear? So how to fill up the electrons or electron fillings in the increasing order of the energy subshell. So first electrons will fill up in this place, then electrons will fill 2s orbital, then 2p orbital, then 3s orbital, then 3p orbital, then 4s orbital, then 3d orbital, then 4p orbital, then 5s, then 4d, and so on. Understood? Now the thing is, maximum in the book, in the most of the books, they will ask you to remember or memorize this one, which for me it's not possible. If it is possible for you, you can go ahead. So if I cannot memorize this one, what to do? Yes, there is one more trick. Copy it ready? Can I erase it? Okay. Okay. So what we can do, first let us write like this. What should we write? First is 1s, 1s, then 2s, 2p, then 3s, 3p, 3d, then 4s, 4p, 4d, 4f. Right? Like this, right? 1s, 2s, 2p, 3s, 4s, 4d, 4d, then 5s, 5p, 5d, and so on. I am not writing anymore. Clear? Now, after that, 6s. Here did I write 6? No, not yet. Okay. So now, how the electrons will be filling? Electrons first will fill this 1s. See? 1s. Then electrons will fill this 2s. See? 2s. Then like this 2p. Then 3s, 2p, 3s. Then like this 3p, 4s, 3p, 4s. Then 3d, 4p, 4s, 3d, 4p, 5s. Then 4d, 5p, 6s, 4d, 5p, 6s. Then like this, the electrons will be getting filled up. Clear? Understood? Should I repeat? Just again I do this one for you. Very easy one. Just make it in a rough form and then you can know where the electrons will fill up. So first write all the subshells. So the subshells are 1s, then 2s, 2p, then 3s, 3p, 3d, then 4s, 4p, 4d, 4f, then 5s, 5p, 5d, 5f, and so on. I am not writing. Then 6s and so on. Now how the electrons will fill? From the top, diagonally, 1s, then 2s, then 2p, 3s, then 3p, 4s, then 3d, 4p, 5s, then 4d, 5p, 6s, then 4a, 5d, 6p, and so on. Clear? Understood how the electrons are getting filled? So, up-bow principle, what up-bow principle is about? Up-bow principle doesn't tell you about how to put in the electrons. It's just help you to find out the energy levels of the subshells or the orbitals. Clear? So, what is up-bow principle? Up-bow principle is N plus L. So energy of the subshell is directly proportional L is, again I am saying, there are S, P, D and F. So here L for S is 0, for P1, for D2, for F3. That's all. So N plus L. Suppose you want to find the energy level of 5D. How? 5. So here it is 5 plus D. D means 2. So 2. So the energy level of 5D is 7. Clear? All clear? Okay. So this is all about above principle, which will help you to find out the energy levels of the subshells or the orbitals. Clear? Okay. Now we will be discussing one more rule, that is Hund's rule. That is Hund's rule. Before I come to Hund's rule, let us do some configurations. Okay. So what we have found out, like we found out that 1s, 2s, 2p, 1s, 2s, 2p, 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s. Dot, 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 dot. Clear? Okay. Now, what are the maximum electrons? What is the maximum electrons in these orbitals they can stay? What is the maximum number of electrons? Maximum electrons will stay. How to find out? See, as of we all know that S is like this, then P, one, two, three, four, five, right? Okay. So in one place, 2 electrons can sit, right? So this is one, this is one, one, two, three, four, 5. Okay, that means and F is 14. I am not drawing that. Clear? F 14. That means in S maximum 2 electrons, in P maximum 6 electrons, sorry, in D maximum 10 electrons, in F maximum 14 electrons. That means S maximum 2, here also 2, P6, S2, P6, 6, 2, P, oh sorry, it is D. D is 10, 10, then 4D 10, F 14 and S again 2. No need to go here, we can do up to this only. Or 4s also only enough, no need to go so far. The maximum configurations will be coming up to this. This is just for your understanding, for the explanation I just wrote. So how is the configuration? 1s, 2s, 1s, then 2s, 2p, then 3s, 3p, 3d, then 4s, 4p, 4d, 4f, then 5s and so on. And S got 2, P got 6, D got 10, F got 14. That means in S maximum 2 electrons can sit, can stay, can occupy. Similarly for P maximum 6 electrons, For D, maximum 10 electrons. Okay. Now, above principle, you remember what is the order? What is the order? Let us in short do that one again. 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, and so on. So first 1s, then 2s, then this one, then this one, then this one. That means when I will fill up the electrons, first I have to fill up 1s1, then 2s, then 2p, then 3s, then 3p, then 4s, 4s, then 3d, then 4p, then 5s, and so on. Right? So first I will fill up 1s, then 2s, then 2p, 3s, then 3p, 4s, 3p, 4s, then 3d, 4p, 5s, 3d, 4p, 5s, and so on. Clear? So this should be my electronic configuration. Now suppose I want to fill up some elements. Say we take the atomic number, like suppose hydrogen. Hydrogen is 1, right? So hydrogen 1. That means hydrogen will be 1s. That means it will be like this. So only one electron. You can either put like this or you can put reverse also. Clear? Okay. Then next comes helium. Z2. After helium what? Lithium. Z3. After lithium what? After lithium, beryllium. After lithium, beryllium is 4. After beryllium, boron. Boron is Z5. And there is carbon, right? Carbon. Z6. Let's do this one first. Clear? Okay. So helium, there is 2. That means 1s and 2s. Am I right? 1s and 2s. So how many electrons? There are 2 electrons. Maximum 2 electrons. Sorry. Why helium 2s? 1s. Now helium 2s, that means maximum electrons can be filled up in S structure is 2. So maximum 2 can be filled up. So now I draw the configuration. One like this, one like this. You can write the opposite also. Then comes for lithium. Lithium is 3. Lithium 3 means lithium is 1s2 and then 2s 2s. That means 3 electrons in S, maximum 2. So S I put 2 and then 1 in this shell. So the configuration will be this is 1s. Here is this is 1s. There are 2 electrons and this is 2s. There will be only 1 electron. Clear? Okay. Now comes for beryllium. Beryllium, there are how many electrons? 4. That means 1s and 2s. Now S, maximum 2 electrons I can put. So here 2, here 2. So how will be the electronic configuration? This is 1s, this is 2s. So here is one and here is one. Next comes for boron. So boron, how to do? Boron 1s, 2s, then 2p. S maximum 2, P maximum 6 I can put. So here I got total 5 electrons. Total 5 electrons. Here 2 and 2, 4. Here I will put 5 electrons. Now 1, 1s, 2s and P. P got 3. That means 1, 2. Now S subshell, there are 2 electrons. So 1. Okay. Now the thing comes. There is one more electron. Try to understand, my dear students. There are total 5 electrons. Now in S I put 2. 1s. 2s I put 2. One more is left. Right? So this one, where should I put? Where should I put? I can put here, I can put here, I can put here, right? Yes, that is the thing. In the book it is always mentioned here. But I tell you, you can even put here also. You can even put here also. Clear? Wherever you put, this will be right. Clear? Understood? Okay, next comes for have I done all correct? Boron 5, 2 and 2, 4 and 1, 5. Okay, now comes for carbon, and this carbon starts the Hans rule. See, carbon, what should be the configuration? It should be 1s, 2s and 2p. So in S maximum 2 I can put, S also 2, and P I can put 6 electrons, right? In 6P I can put 6 electrons, but total I got 6 electrons. Here I put 2, here I put 2, so some more left 2. That means these 2 electrons will be in P subshell. Now let's do the configuration. So this is 1s, this is 2s, and this one is 2p. This one is 2p. So now, okay, very good. This one already done. This one already done. 2 and 2, 4. Now 2. Now how will you put 2? See. Suppose this is this one. I am drawing it here for your understanding. I got to put 2 electrons. There are 2. Maybe say 2 of you are there. There are 3 rooms. So how can you stay? Both of you can stay in the same room. Now there are 3 rooms. Both of you can stay here, or you will say no, I will stay here, sir. Okay? No, the owner will say no. Both of you have to stay here. So you can stay here like this, or you will say that no, we always fight with each other. We will not stay together. We will stay here. He will say no, I want the roadside room like this. You will say no, I will stay like this. Opposite spin. That means there is a big problem, or it's a matter of permutations, right? How to accommodate 2 electrons in this one. And here comes the Hans rule. Can I erase it? Okay. Never. Yes, I have to. I hope you all have copied, right? Now comes Hans rule. Not hands rule. A lot of times I found my students saying hands rule, not hands, Hans rule. So what does Hans rule state? Hans rule states that electrons prefer to stay unpaired as long as possible. I think in the book it is written electrons prefer to remain unpaired as far as possible. I think maybe I am wrong here. Always try to give the exact language of the book, okay, especially for the rules, for the principles. So Hund's rule, what it says? It says that electrons prefer to stay unpaired as long as possible, as far as possible. It should be as far as possible, and that should be even better. I change this one so that later on no controversy comes. Otherwise you will say that Stan is teaching us wrong thing. Electrons prefer to remain unpaired as far as possible. So electrons will prefer to remain unpaired as far as possible. That means the one which I told you, that both of you can stay in the same room, that is not possible. They will not stay together. They will not be paired up. They are very fond of, privateness. We want private rooms. I will stay alone. Okay. So it might be like this, like this. It might be here and there. Now, how they will stay in different rooms? For that also, Hans gave us one explanation. That is electron. Electrons in a subshell. Electrons in a subshell. Electrons in a subshell are paired only. Electrons in a subshell are paired only when all the possibles are paired only when all the orbitals are filled. All the orbitals of a subshell are filled in a parallel spin. When all the orbitals of a subshell is half filled with, orbitals of a subshell are half filled with parallel spin. So this is Hund's rule. So what Hunt says? Hund's rule states that electrons prefer to remain unpaired as far as possible. Number one. So when I am getting two electrons here, these two electrons will never occupy one room. Clear? They will never occupy one room. So what will happen? How they will stay? Electrons in a subshell are paired only when all the orbitals of a subshell are half filled. That means suppose this 2p2, 2p, here it will be 1, 2, 3. So this is half filled because each orbital can have two electrons, right? So 1 means half filled. So once suppose there are 4 electrons. Now these 3 are already filled. Then one more electron will come and occupy this place. Understood? So first say suppose Here you got 2 electrons. Okay, 2 electrons. So one you have to put here, one you have to put here. Now you have got 3 electrons. One here, one here, one here. Then you got 4 electrons. Now this is already half filled 4 electrons. So one here, and always remember parallel spin. All should be in the same spin. So this is already half filled. Now one more electron can come and stay here, or can come and stay here, or can come and stay here. This is all about understood. Clear? Understood? So Acco principle, Hund's rule. Clear? Again let me explain what is Hund's rule. When normally by Acco principle we were filling up the orbitals and their subshells. Now suddenly we came across carbon. In carbon we got a bit of confusion, like these 2 subshells are already filled up, but remaining 2 electrons where to put. So there Hund's rule helps us. Hund's rule states us that electrons prefer to remain unpaired as far as possible. That means until and unless all these orbitals are filled up, half filled, you cannot put 2 electrons in one orbital. They will never be paired. Suppose there are 3, you can put here 2, you can put here 1, right? No, but cannot. First you have to put 1, 2, 3. Understood? And electrons in a subshell are only paired when all the orbitals are half filled and they are with a parallel spin. Clear? So up to carbon we have done, right? So we have finished up to carbon, that is active number 6. Active number 6. Okay, next after carbon what comes? After carbon comes nitrogen 7, right? Yes. So after carbon comes nitrogen. Nitrogen is 7. Then nitrogen, carbon, nitrogen, oxygen. Oxygen Z8. After oxygen, fluorine. Fluorine is Z9. After fluorine, sodium is 11. 10. Who is 10? Who is 10? 10 I am forgetting. Who is 10? Oxygen. Sorry, I forgot. Who is 10? Fluorine 9 I remember. 10 I forgot. Then the sodium. Sodium is 11. Sodium is 11. After sodium is magnesium. Sodium is 11. Magnesium is 12. After magnesium, I think aluminium. Okay, first let us do these things. Clear? Practice this one. Okay, it will help you a lot. Okay, now comes for nitrogen. Nitrogen 7. Nitrogen 7 means 1s, 2s, 2p. 7. Here I can put 2, here I can put 2, 2 and 2, 4 and 7. That means here I will be putting 3, right? Okay. So how to do 1s1, 1s, 2s and then 2p. Okay. So here 2 electrons, here 2 electrons, some more 3 electrons. Clear? 2, 4 and 3, 7. Okay, nitrogen. 10, who is 10? Neon. Okay. 4. Now see here, I got 1s, I got 2s, and I got 2p. So how to fill up the electrons? 2, here 2, here 2. Now 4. First I fill up with the parallel spin, then one more left. I can either put here, 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 anywhere I can put. Then comes fluorine. Fluorine 1s, 2s, 2p. So S means 2, 2, 2 and 2, 4, and P is 5. 5. So how to put 1s, 2s, 2p. That means here 2, here 2, and here 5. So first I fill up with parallel spin, then some more 2. This one, this one. I can put the other one also, no problem. Then comes sodium. Sodium 1s, 2s, 2p. 1s, 2s, 2p. So here 2, 2, p maximum 6. 2 and 2, 4 and 6, 10. Some more. That means for sodium I need to open my another one shell. After 2p, which shell? After 2p you see, after 2p 3s. Clear? You see here. First 1s, then 2s, then 2p, but 2p is also filled up, 10. 2 and 2, 4 and 6, 10. But atomic number is 11. So another one electron. So after 2p is 3s. Don't forget this one. Very, very important. Clear? So after 2p is 3s. So I have to open my 3s shell. So 3s maximum 2 electrons can put. But here I got 2, 2, 4, 1, 6, 10 electrons. Okay. Now up to this one means, see, this, okay, so this is 1s, 2s, 2p, then 3s, right? So here I put 2 electrons, here I put 2 electrons, here I put 6 electrons, here I put 6 electrons, 2, 2, 4, 4 and 6, 10, and 1. So here I put 1 electron. Next comes magnesium. Magnesium, what? Magnesium, 1s, 2s, 2p, 3s. So magnesium, here I got 2, 2p6, here also 2, 2, 2, 4 and 6, 10, 10 and 2, 12. Very easy. Here up to this I am not writing, it should be same. I am writing only the last one, 3s. So this is 3s. It will be fulfilled. Understood? This one will be same here, but I am not writing here. Then comes for aluminium. Aluminium, oh no. Yes, aluminium. Aluminium 1s, 2s, 2p, 3s. Now here maximum 2, 2, 6, 2, 2, 2, 4 and 6, 10 and 12. One more. That means I have to open up another one subshell. So 3s. After 3s, 3p. That means now comes 3p. So 3p there will be, I will putting 1 electron. Now see. 2 and 2, 4, 4 and 6, 10, 10 and 3, 13. Got it? Now, here you see, up to this stem, that is 2, 2, 4 and 6, 10 electrons. Now, here is this is my 3s and this is my 3p. Okay. Now 3s, up to this I didn't draw. 1s, 2s, 2p. 3s, there are 2 electrons, and 3p, 1 I can put anywhere. So this is 3p. So up to 13, up to aluminium we have done. Clear? Understood everybody? Okay. Like this, 13, 14, 15, 16, 17, 18, same thing. Please try. I will show you some more from potassium. From potassium, it's 18, right? Sorry, 19. Potassium is 19. The rest you should practice. Not you should, but you must practice. I tell you, I repeatedly tell you, this all you should practice. Clear? Okay. So up to 13 we did. That means up to okay. So up to aluminum we did. Now let us start from 19. Potassium is 19. Am I right? Yes, I think I am right. Potassium is 19. After potassium, calcium. After potassium, calcium. Then after calcium, potassium, calcium. I forget. Next, the main thing which we have to come across is chromium. We have to come across to chromium. Then after chromium is 26, I know, iron. 26 is iron. Then cobalt is 27. Cobalt is 27. Cobalt is 27. Then something. Then again copper. Copper is 29. This one also very important. And zinc is 30, I suppose. But I need to explain these two only. Okay, but again I tell you, please do practice up to 1 to 30. From hydrogen to zinc, zinc is 30. Clear? Okay. So let's start. So potassium is 1s, 2s, 2p, 3s, 3p. That means S is 2, 2, 6, 2, 6. Right? That means how many? 2 and 4, 4 and 6, 10, 10 and 12, 12 and 6, 18. Am I right? So 18. But here is 19. That means I have to open the next energy level. So after 3p is 4s. So 4s maximum 2 electrons, but I need to put only 1 electron. So how will be the configuration? See, 2 and 4, 4 and 6, 10, 10 and 8, 18. So up to this one I am not drawing, okay? Up to this one 18 already filled up. So I am drawing only this shell, 4s. 4s, 1 electron, anyone you can draw. Okay, next comes for calcium. Calcium 1s, 2s, 2p, 3s, 3p, 4s, 4s. Okay. So 2, 2, 4, 6, 10, 12, 18 and 2, 18. So up to 18 I know, up to 18. So only my 4s subshell, there are 2 electrons, so I put 2 electrons. So that is done for calcium. Similarly after calcium, 1s, 2s, 2p, 3s, 3p, 4s. So here 2, 2, 6, 2, 6, 2. 2 to 4 and 2 6, 6, 12, 12 and 6, 18, 20. That means up to here 20. So after 4s is 3d. 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 So in this 3d, how many 4 electrons I have to fill up? 2 to 4, 10, 20. So up to here is 20. Okay? Okay. So up to this I am not drawing. I am drawing only the 3D shell. So 3D shell D means 10. Okay, I draw this one also. 4s and 3D. 4s, 1, 2, 3, 4. This is 3d. Now 4s2, 4s2 and 3d4. That means 1, 2, 3, 4. Right? According to my electronic configuration, chromium, whose atomic number means number of electrons 24, should be arranged like this. Yes or no? 2 and 2 4, 6, 10, 12, 18, 20 and 4, 24. So up to here all finished. Then I am going to the next energy level. So here 1, 2, 3, 4. Right? No. There is some exception. It will not be like this. It will be see, one thing let me tell you, in chemistry, especially in the periodic table and the atomic structure chapters or this subject, till yet the final discovery or invention or whatever you say has not yet been done. Understood what I am saying? It's not yet been completed. Day by day the scientists are getting some new things after the experiments, and then again they are coming out with some law. This law, let me tell you what they say. They are saying that, what should I write? An atom is more stable when just check the book for this language, half filled or full filled. So the scientists are saying that when the orbitals are half filled or full filled, just note right here atom, orbitals. An orbital is more stable when half filled or full filled. Now see, here this one is full filled but this one is not. So what happens, from here one electron jumps there and clear? Understood? So this is the electronic configuration of chromium. So chromium. So there is one exception for chromium, and similarly for iron. Iron same thing, 1s, 2s, 2p, 3s, 3p, 4s, 3D. So here 2, 2, 4, 16, 12, 18, 20, here 6, here 6. So up to this same, that means up to this 18 same, right? 2 to 4 same. So here 4s and 1, 2, 3, 4, 3D. So here 2 to 4, 4 is 16, 12, 18, 20, 26. So here got 2 and here 1, 2, 3, 4, 5 and here you put 1, 6. So that goes for iron. For cobalt up to this same. This is 20. So here 3D I can accommodate maximum 10 electrons. Here I need to put only 7. I need to put only 7. So 7, what I should do? I put here one more like this. Clear? Okay. Then comes after cobalt, nickel I suppose. After cobalt, nickel. Okay. Next comes for copper. Copper also, see copper. This one I am not doing. Okay. This one try at home. Copper it comes for 1s, 2s, 2p, 3s, 4p. 1s, 2s, 2p, 3s, 4p, 4s, 3d. So 2, 2, 6, 2, 6, 2, 2 to 4, 4, 16, 12, 18, 20 and here 9. That means it should be, I am not drawing up to this, I am just drawing this 2. It should be 1, 2, 3, 4. It should be 1, 2, 3, 4, 5 and then 1, 2, 3, 4. It should be like this, right? Up to this 18, 20, 22, 24, 26, 28 and 129, right? Now see, again comes this row. This is fulfilled, okay, but this one not. So what should we do? We jump one electron from here, we put it here. Now see what happens. This shell is also half filled, so stable, and this one is also fulfilled, stable. So like for chromium and copper, the electronic configuration will be a bit, different. Just to maintain this stability of the orbitals. So first you have to look out that if by shifting one electron the orbitals are getting either half filled or full filled, so you should always do that. So this is all about electronic configuration, and I think I have explained all the things, or I have showed you all the tricks or all the principles that you should use for the electronic configuration. Now it's your turn to do what? 1 to 30 from hydrogen to zinc. Do all the configurations. Please do all the configurations. Okay? Bye bye.